So here's today's lesson on single variable expressions. This is our introductory lesson to algebra. And so before we begin, I think it's important that we have a common understanding of how algebra is different than simple arithmetic. So when you look at these expression and equations, then you'll see that there's some obvious differences between some of the mathematics we've been doing and what we see here. And I think the most obvious thing is the fact that we see some letters here. Now those letters are called variables, and they're referred to as variables because their value sometimes can vary. It's a value that we don't know, and so we're replacing it by a letter or a symbol as sort of a placeholder before we figure out what it is or before we decide what it is. So let me give you an example. Now, when I look at this expression on the left, 3x plus 5, I see that I have this x here, and I may decide that that value for x is 1. And so if I do that, then what this means is that I'm going to substitute a value in for x that is 1 and then work out the expression. Let me demonstrate what I mean. So, if I decide that x is equal to 1, or if a question tells me that x is 1, what that means is that I'm going to replace the x in the expression by the value that is given, in this case 1. So, when I see 3x, what that really means is that I'm multiplying those values together. So it really means 3 times x. And so 3 times 1, in this case, because I've decided that x is 1, plus the 5. And so I can work that out. 3 times 1, of course, is 3. And then I'm going to add on that 5. And so the total expression, the expression has a value of 8 when x is 1. And so, of course, I can change the value of x to another value, and that will give me a different answer for that expression. Now, what I'm seeing here on the right is what we call an algebraic equation. And what makes it an algebraic equation is the fact that we see this equal sign there. And that means that whatever I put in for y, the value for y has to make the left side of this expression equal to the right side of this expression. Otherwise, the equation doesn't hold true. So this is a case where I can actually solve for the value of y. And later on in this unit, what we'll do is we'll practice some of the steps towards getting the answer for y, getting the solution to this equation. So let's talk a little bit more about terminology. So I've already mentioned that the fancy word for the letter or symbol is variable. And again, it's called the variable because its value can change sometimes. We don't know its value, so it can vary. It's a variable. Now, the term in this that cannot change is called the constant. So in this first example here, we have 5 as our constant. So variable versus the constant. Now, each little part of the equation that is separated by a plus or a minus, addition or subtraction, is called a term. So in this case, I have a term in 3x, and I have a different term in 5. So this is a 2-term expression, and we'll talk about the language for that in a little bit later on in this lesson. So the term that has the variable in it is called the variable term. And the term that does not have the variable in it, the term that doesn't change, is referred to as the constant term. Constant meaning it's going to be constantly 5. It's never going to change from being 5. All right? It's difficult to comment on that in terms of the equation on the right, but let's try to do that. So when I look at the second equation, or the second piece of algebra, I can see that I definitely have a variable term here, and I have some constant terms here. Now the difference is in the left and the right side from it being an equation is that I know that at some point I can probably deal with the negative 5 and the 20 and simplify that into a single term. So those are some pointers. Let's look at an example to help us deepen our understanding of some of this terminology. Okay, so in this example, I'm asking you to identify the number of terms in the expression, the variable term, the coefficient of the variable, which I didn't speak about, but I will in this case, and the constant term. All right, so looking at this first example here, I can see that I have 6a plus 8. And so the first question asks me to talk about what the number of terms are. And so remember, terms are separated by addition or subtraction. So when I look at this, I can see that I have a term in 6a and I have a term in 8. And so the answer to the number of terms in the expression is that there are 2 terms. The variable term. All right, so the variable term in this case, remember, is the term that has the letter or the symbol. And in this case, the variable is a, and so the variable term is 6a. Now, the coefficient of the variable happens to be the value that the variable is being multiplied by. And so since my variable is a, well, I'm looking to see what is a being multiplied by in this case. Well, it's being multiplied by 6. So the coefficient of the variable is 6. Lastly, the constant term. Now, I think we're pretty good with that. The constant term is the term that is unchanging, and that is my 8. Let's look at another example before we move on. All right, so it's very important that when you see an expression, an algebraic expression, that has a variable term and a constant term, that when you look at the variable term, if there doesn't seem to be any coefficient, like in this case, that you remember that when you see something like x, that really means that you have 1x, not 0x, but 1x. And so I often recommend to students that they actually put in the 1 as a reminder that they need to consider that as being 1x and not 0x. So the number of terms in this expression, I see that there are also 2 terms. The variable term is my 1x, or just simply x. The coefficient of the variable in this case happens to be 1. It's the value being multiplied by the variable. And the constant term is the 2 because it is not able to be changed. All right, so let me outline some really important terms that you need to know and that I'll be using at different points.
Mrs. Doyle's co-op student.
Little interruption there from Mrs. Doyle. Let's carry on. So polynomial is a word that we sometimes use for algebraic expressions. So I might say polynomial, I might say algebraic expression. They really, for our purposes, mean the same thing. So, but there are some specialized types of polynomials that are important to discuss. So a monomial is an expression with 1 term. So, well, what does that mean? The prefix mono means 1. So an expression with 1 term, well, what are some examples of that? I could have just, 2a. That would have 1 term in it. I could have simply 5. I could have something like x squared. But notice that each of these is sort of standalone. There's no, I'm not adding it or subtracting it to or from anything, any other term. All right, so that is what a monomial is. A binomial, well, the prefix bi means 2. So a binomial is an expression with 2 terms. And so a good example of that would be if I had, let's say, 3a minus 1. I can see that I have 1 and 2 terms here. I could have something like x squared minus x. I can't combine these terms, and so this is considered a binomial. Lastly, I have a third word that we may use, which is trinomial. So tri meaning 3, think like triathlon or something like that, 3 terms. So a good example of that would be x squared plus minus 7, for example. Let's say that I have 1, 2, 3 terms here in the expression, and I can't combine any of those terms to reduce the total number of terms. So it is considered a trinomial. So I've sort of been hinting at this in the last little section, which is that, you know, only terms that are considered to be like terms can actually be combined, okay, which means that we can simplify it into a single expression. So in order for terms to be considered like terms, they have to have the same variable, but also the same exponent on the variable itself. So let's look at a few examples that I can show you to help you understand what we mean by this. So in the first example, right here, well, this example number 1, I can see when I look at this that I have 5x and I have 2x. Well, they have the same variable and the same exponent on the variable. The exponent, we don't put it in, but it's understood to be 1. So those are considered like terms, and we could combine them. And I'll talk about that in a bit. In the next example, let's look at that. Well, I have 5x and I have 2y. Well, those are not like terms. And the reason that they're not like terms is because I can't add x's and y's together. They're simply not the same. So they would not be considered like terms. Next example. And so when I look at this, and this is when students often make mistakes, where they think that they can add an x with an x squared. But if you look carefully, you know, the exponent on the x term is 1, and the exponent on the squared term is 2. These are not like terms, and so they cannot be combined. And, you know, I see that a lot over the years. I've seen students think that they can add a 5x to a 2x squared and make an x cubed, and you simply can't do that. So some important pointers to remember. So again, it's important to remember that only like terms can be combined to form a single term. And so when we do that, well, I like to think of that variable as representing something real, because it helps me to make sense of what's going on here. So, you know, in this case, I have 5 x's that I'm adding to 2 more x's. Well, if that x was representing apples, I would say, well, if I have 5 apples and I add 2 more apples to that, how many apples do I have? Well, I have 7 apples. So in the same way, 5x plus 2x will give me 7x in total. Okay, looking at a similar but slightly different example, I can see that I have 5x and 2y. So in this case, the terms are not like terms. I cannot gather them together. That's sort of like saying if I had 5 apples and 2 oranges, that I would end up with 5 or 7 apple oranges.
Aiden to the office, please. Aiden Basham to the office.
Funny. And so there's a total. I really can't do anything with that. And so, you know, the only thing I possibly could do is simply rewrite this expression exactly as is, because there's really not a whole lot to be done there. Or I can simply say, you know, simplified already or something like that. There's nothing else I can do with it. Those are not like terms, and so I therefore cannot combine them. So let's look at a few simple examples. We'll get into this in more detail as we move forward. So in this first, it's really important to read what the question is asking of you, because, you know, some students tend to jump right into it without really thinking about what it is that they have to do. But in this case, they're asking us to simplify where possible. So that implies that maybe it might not be possible to simplify. So in this case, I have 7x plus x. So remembering that x really means 1x, I go ahead and I say, well, if I have 7 x's plus 1 more x, that gives me a total of 8x. So in example B, I'm looking to see that my variables are the same and the exponents on them are the same, and in this case they are. So I simply go ahead and add my coefficients, and that will give me...
Aiden Beauchamp to the office, please. Aiden Beauchamp.
And that will give me 7x squared. Okay, and in the last example, I'm going to hurry up and do this quickly. 2x and 8 are not like terms, so there's nothing I can do, so it's not possible.